Hey everyone, in this example we have points A, B, C and they are collinear, which means that they lie on the same line. Alright, so for example we have this particular line. The first point here is A, somewhere in the middle or somewhere along the line is B, and let's say the end point here is C. And we such that AB is to BC is 1:2. So it is a ratio, alright, which should be an indication that we might need to use what we have learned earlier, the ratio theorem. And from here we know that OA is 1,4. So let's say we draw origin O. Let me draw that line a bit better. OA. Again, it's good to have visual representation if you're not confident. OA is 1,4, and now OB is -3,1. And finally, they want us to find OC. So it should be quite or kind of obvious that you need to use the ratio theorem, right? Because you have 3 points on the same line and you're given the ratio. What is different now is that if we recall from the ratio theorem, we're looking at the two outermost vectors, right? This vector and the outer and the other outer vector. Instead now, we are given the outer one of the outer vector and the inner vector, and then to find one of the outer vector instead. So it's just basically a simple tweak, but the method is still the same. Just apply the formula. Alright, so if we recall the formula, with the inner vector OB equals to opposite. Alright, opposite times opposite. So we have 2 of OA plus 1 of OC, so simply OC, over, well, the sum of the ratios. So 1 plus 2 is 3. So basically it's 2/3 of OA plus 1/3 of OC. Alright, and because we want to find OC, we can kind of simplify this. We get 3OB minus 2OA equals to the vector OC. So we have the vector OC equals to 3 of OB. So it's 3 minus 3,1 minus away 2 of 1,4. And if we do this fast enough, minus 11 minus 5. Alright, minus 9 minus 2 is minus 11. 3 minus 8 is minus 5. Alright, and that is simply the vector OC. Now, we now have two other points, right? S is 3, 5. R is K minus 1, where K is a real value. And we are told that the line SR is parallel to line AB. So I think it's quite simple, right? Let's say we name this part 1 and now we have this part as part 2. Alright, so since we know that SR is parallel to line AB, SR must be a multiple of AB. Rather, the vector SR must be a multiple of the vector AB. So let's first find what is the multiple, or let's first find what's the vector AB. Alright, so AB, vector AB is simply OA minus, or rather OB minus OA. And I think it's quite simple. Minus 4 minus 3. Alright, now let's look at SR. SR again is just simply K minus 3 and minus 1 minus 5 minus 6. We want K minus 3 equals to H of minus 4 minus 3, where H is a constant, right? Because it must be a multiple of the vector AB. And from here, we know that H equals to 2. Alright, because minus 6 equals to minus 3H. H must be 2. Therefore, we now have K minus 3 equals to minus 4 times 2 minus 8. K equals to minus 5. And that is how we can find the value of K. Alright, so just remember, when there is a pair of parallel lines, the vectors of these two lines are a scalar multiple, or aka just a multiple of each other. Alright, and therefore if we have this step right here, H minus 1 minus 3, basically H is a real value. It's a scalar multiple of AB because SR is parallel to AB. Then we just solve from there. Alright, so this is a example on ratio theorem, and more importantly actually the idea of parallel lines where one vector is actually a scalar multiple of the other.